This webinar will be recorded, so I'm starting the recording now, and you can access the recording and the PDF of the slides, which will be sent out in a follow-up email within a day or two of this broadcast. So I am Joanne Backrack. I'm on the line today coming from Portland, Maine, and I'll be the moderator for today. We also have Eric Dellinger, who's calling in remotely from Kepware, and he is a product manager for IoT. He'll be doing a presentation for the Kepware side. Ray Labby, a senior applications engineer here, who will be doing a demo for Kepware. And then Eric Dean, who's joining us from Splunk. Eric is the product manager for IoT and business analytics at Splunk. And Eric, if you wanted to just introduce yourself quickly. Are you there, Eric?
Yeah, hey everybody. Yep, I'm here. Thanks, Joanne.
Great.
Hey everybody. Thanks for joining today. Again, my name is Eric Dean, and I'm the product manager for IoT products at Splunk. And I'm looking forward to showing you all how Kepware and Splunk can work together and what you can do with industrial data in Splunk.
Okay, thanks so much, Eric. So the agenda for today, we're going to talk quickly about Kepware technologies and a little background on data flow, industrial IoT, and how KepServerX fits in, some use cases, and a quick demo. And then we'll talk briefly about our IoT Alliance program. And then we'll hand it over to Splunk, who's going to talk to you about their solution and do a really great demo as well. So with that, I'm just going to hand the presentation over to Eric Dellinger, who will come in and do the presentation about Kepware technologies. So Eric, are you there?
I am. Thanks, Joanne. Hello, everybody, and thanks for joining the webinar. I'm really excited today to talk about Splunk. They are one of our first partners, or our actually first partner in our IoT Alliance program. We've been working with them for several years now, so I think they have some really great technology that you guys will really enjoy seeing here today. But with that, I'd like to get started. As Joanne mentioned, we'll kind of go through a few slides here, and then I'll hand it over to Ray, who will do kind of the more important piece, kind of just demonstrating our product, the industrial data forwarder for Splunk that we developed a little over 2 years ago. So with that, let's see. Can everyone hear me?
I can hear you, Eric. You're good.
Okay, thank you. So just a little bit about Kepware. We were established in 1995. We're located in Portland, Maine. 20 plus years now of developing just connectivity to the industrial floor. Really focused on the industrial automation market. Different verticals, discrete manufacturing, think automotive, process manufacturing, oil and gas industry. Batch processing, so I think food and beverage, a lot of, pretty much any industrial environment Kepware can be found. We are connected globally, so we have a preferred network of channel internationally that can help sell and support our products. And then here in the U.S., we obviously sell direct, but we also sell through channel. And go ahead, Joanne, next slide. And so before we kind of get into all of this, I do want to kind of go back and talk about the traditional data flow. So traditionally in industrial automation markets, data is flowed in this kind of what you'll see here. This is kind of a diagram similar to the ISA 95 model, where data flows from your production, your assets, up into controllers, then into controllers being PLCs and different types of sensors and things like that, into kind of your HMI, SCADA type applications for visualization and control of those devices and some of the operations, and then into more of your manufacturing operations management applications, MES, manufacturing execution systems, and then into your business systems. This could be ERP, this could be your CRM, this could be big data analytics, it could be any number of applications. So traditionally, the data is flowed up in this kind of step model. Go ahead, Joanne, next slide. But before we kind of talk about how IoT has kind of changed that model, I kind of want to just kind of give you a basic sense of what it is. Very basic idea of how we define IoT, whether it's industrial Internet of Things, manufacturing, smart manufacturing, Industry 4.0, whatever you call it. At the heart of it, it's really about connecting things in your industrial environment, moving it into the internet, into some application to provide analytics so we can make better decisions. So really, from a simplistic standpoint, that's how we kind of define the Internet of Things. So really just connecting your assets so you can make better decisions, with the purpose of either saving money or making money at an end user site. So next slide. So taking this ISA 95 model or the traditional data flow model where you're making this step with data makes a step each way through the process, this kind of model has kind of been flipped on its edge with the Internet of Things. So and Kepware really kind of making this control data, this sensor data, this industrial data directly available to all applications. So whether it's your HMI SCADA, all the way up to your MES, ERP, and now these IoT platforms that Splunk will demonstrate later, they can get this data directly from Kepware, from those sensors, from that machine equipment. Next slide. You can just go through and build this out. Kepware, to kind of give you a better sense of Kepware, what we really focus on, again, is just moving data from point A to point B. So really connecting these assets, these controllers, these devices that you find on your manufacturing environment, manufacturing being any industrial environment, and then moving that data into other applications. Next slide, Joanne. And this is basically an architecture of what you might see in an industrial environment. On the top left, you'll see your HMI, SCADA, Historian, MES type applications. This is the traditional data, where data traditionally flowed from Kepware. Moving down the stack, you obviously have your PLCs, RTUs, which are then connected to your sensors, drives, and motors and things like that. All this data moves up into Kepware. We can connect to all these things. And now on the right side, we can move data into the cloud or into big data analytics platforms such as Splunk. What's missing there is obviously MQTT and REST. Splunk can ingest those types of that type of data. However, we also have a direct pipe of to move data into Splunk. So next slide. Just want to kind of cover a quick 3 quick use cases. Go ahead. Before we do that, though, LNS Research did a quick study on they polled their customer base and said, how are you implementing IoT? And this is a pretty hefty list, but we picked out 3: remote monitoring, energy efficiency, and supplier visibility, and just so we can demonstrate a couple of use cases that we have in the market today. Go ahead, Joanne. We have a poll question. Let you have a minute to go through this.
So if everybody can see this poll question, just answer it very quickly on your screen. Just kind of going off of Eric's graph that he showed up there a moment ago, wondering if you're using IoT for anything specific like remote monitoring, energy efficiency. We've also heard some buzz about using IoT for OEE, or perhaps there's a reason we didn't list here. So just getting an idea who on the line is actually considering implementing these sort of IoT solutions. So if you take a moment to answer that question, go ahead and vote in the poll. I'll leave that open for a few more seconds. And once enough people have voted, which it looks like a large majority of people have voted here, I'll close this out and share the results with you. So it looks like a lot of people are looking at remote monitoring and perhaps OEE, or overall equipment effectiveness, so that's great. So Eric, I'll go ahead and let you continue with those use cases.
Perfect. Thanks, Joanne. So this use case here, I think Splunk is also going to talk about this use case, but this is actually a Kepware Splunk use case in Singapore, where a large chiller manufacturer has really is essentially installing Kepware locally on these devices and moving this data up into the cloud into Splunk, Splunk's big data solution for remote monitoring, so they're doing predictive analytics on the stuff, and really providing a new service to their customers who actually are who own these chillers. So it's a really cool predictive maintenance application. Now this chiller manufacturer is providing some predictive maintenance, so they're monitoring this equipment remotely, and they can send service techs out to fix these chillers when they are predicting a failure and service them, so there's less downtime. Next use case. A really interesting application, monitoring use case where really this manufacturer of these components was they were having some major quality issues, and one of the main reasons they were having these quality issues was, they had very little automation in place. So as they built their automation, they recognized that they could also take this industrial control data, so first just monitoring the data locally through an HMI, but then also taking that same data and moving it into their ERP system, providing some OEE KPIs, so overall equipment effectiveness. And they've already seen a tremendous increase in product quality and just visibility into their manufacturing processes. There was a lot of errors. A lot of the data collection was happening over a clipboard, so manually writing down values and things like that. So now they're able to do this through automation. Next use case. And the last use case we will talk about is supplier visibility. A very large apparel manufacturer, many distribution centers, and really they are really logging the transactions now using Kepware and our IoT Gateway product into their warehouse management system. So so the retailer can actually get access to this supply chain and understand where their orders are within the warehouse. So really good use case there on providing supplier visibility through IoT. And next slide, Joanna. Next, I just want to briefly talk about our IoT Alliance program, which is basically a strategic network of leading IoT solution providers like Splunk today. We are working with many partners in the IoT space. Most of them are IoT platforms, big data analytics. So really, with the goal of really providing solutions to the market, reducing our customers' risk, ensuring that we have connectivity and the solutions work well together. So next. And really, just to kind of piggyback on that, LNS really defined, which is one of the research firms that Kepware uses, defines an IoT platform through its components. 4 major components: connectivity, cloud, big data analytics, and application development. Kepware is obviously just the connectivity piece. We are the network infrastructure, the how you move data within an industrial environment. And then there are other applications that are either cloud-based, that provide analytics, or application development, much like Splunk, who provide the rest of those components. One of the great things that you'll see today is from Splunk is their search and data exploration piece. I think that's extremely powerful tool that they provide. So next, Joanne.
Okay, great. Thanks so much, Eric. So I think that closes out your section of the presentation. And before I pass it over to before I pass it over to Ray, I'm just going to launch one more poll question here. So are you currently using any software from Kepware or Splunk? Just getting an idea of our audience here. So yes from Kepware, yes from Splunk, or perhaps you're using software from both of us. So just seeing who's on the webinar. So take a second to vote there, and then I'm going to pass it over to our senior applications engineer on the line here, Ray Labby, who's going to do a demo for the Kepware side of things. So take a moment to vote. If you haven't voted yet, that's great. Just a reminder that also the the questions pane. You can type your questions into that pane, and the organizers or the application engineers on the line here with me will answer your question. So any question you have, you can answer or you can ask through that questions pane. So I'll just share that with you. Looks like we have a lot of Kepware customers on the line today, but also Splunk customers, some people using both, so that's really great to see, and we're happy you joined us. So now I'm going to pass that over to Ray Labby and make him the presenter in order for you to see our great demo we have here.
Excellent. Thanks, guys. Sorry about the feedback. My laptop decided to
muted.
Responding in the question pane. Excellent. Looks like we have a few people that are responding. So what I'm going to step us through here, once I share my screen, is just talking a little bit about KepServer EX's configuration and how we can easily configure KepServer EX and the industrial data forwarder for Splunk to get data into Splunk. So a lot of you are current Kepware customers. For those that aren't, what we see here is the configuration tool for KepServer EX. And this is your user interface to configure the connectivity to the various devices within your environment. So the tree structure here on the left are objects that are called channels and devices, and these are the configuration points that you make in KepServer EX to identify what protocol or language you're going to communicate with a device, and then which device you want to communicate with. So common properties you'll find are the different drivers, whether it's a Siemens or Allen Bradley driver that you're going to use, and then individual device properties such as IP addresses, the ports that are available to connect to them, certain properties that are unique or specific to the protocol that you're leveraging and using. So one of the advanced plugins that we have as part of KepServer EX is the industrial data forwarder for Splunk. And what I'm going to step through here is just a quick demonstration of how you can easily configure this to start publishing data up to a Splunk Enterprise or a Splunk Cloud solution, depending on if you're using a on-premise or maybe a cloud-based solution with Splunk. So creating a Splunk connection is pretty straightforward. You just identify, label the name of the connection to give it some point of reference, maybe what instance, whether it's a specific instance at a facility that you're pointing this connection to in Splunk, or if it's a cloud-based solution. And then you identify the IP or host name that you want to forward, that you're going to be forwarding that data to. So this is going to be the IP address or the host name of where the Splunk instance is installed. And then lastly, the last configuration parameter is the port value. And this is the port value that you're going to configure in Splunk that's going to be listening for KepServer EX to publish data to. And once you've identified those properties and configured them, click OK. And what we can see down here is in the event log here, I have a local instance of Splunk Enterprise running on my machine, and you can see that the IDF for Splunk has connected to the Splunk Enterprise server that is running locally. So the next thing we want to do is identify what data points or what tags do we want to forward into the Splunk Enterprise data store. So what I'm going to do is use the multi-tag browser, there we go, the multi-tag browser here, where I can select the device that I want to access data points for, and either multi-select a few different data points that I want to forward into Splunk, or I can right-click and add all the tags beneath a particular section in the configuration tree on the left. Now, all of these data points are going to be forwarded into Splunk, but we want to identify a few other parameters. The update rate. How often are we polling the device for the data that we want to push into Splunk? This is where you configure basically your poll or your scan rate if you're familiar with OPC in the industrial space. By default, it will be set to 1,000 milliseconds, but you can set that to whatever makes sense for your application. We also have a deadband parameter where you can identify a rate of change or a window of change from the last known value to determine when we want to publish data into Splunk. So this is a percentage of the range of the signal that we're going to be forwarding. And then we also have a free-form metadata field where you can create key value pairs to identify things such as what Splunk instance is this, what device is this data coming from, maybe there's a serial number that you want to append as metadata to the tag information that's being forwarded into Splunk. So we could do something like serial equals, and then put in a random serial number, for instance, maybe that's associated with the device that's forwarding this data into Splunk. So now when we go back into Kepserver's configuration tool, we can see here all of the data points that we've configured. We can see that the metadata here is going to be appended to all the data change events that are being forwarded to Splunk. And then we could also see down here that the demo timer started because we're actually polling the ControlLogix Ethernet device that we have configured. So now what I'm going to do is hop into Splunk real quick and show you how you configure Splunk to access this data from Kepserver EX. So the input that we're using is what we call a TCP input for the Splunk interface. So what we can do is go to the data inputs and go to the TCP type. And this is where you can see you're going to create a TCP input that's configured into Splunk to identify the open port that Kepserver is going to be publishing this data to. And really configuring the TCP input is pretty straightforward. You can give it a source name to override the basically the the host property that's appended with this data, and then you can identify the source type as well, just a free-form text indicating that it's Kepserver EX, or maybe this is a location, etc. And you're also identifying essentially the TCP port number here, which is 51112 for this demonstration. So it's pretty quick and easy to create the TCP input. So now let's go ahead and just do a quick search on data for Splunk. And what we should be able to see, so I go and search on different sources, what we should see is a few different events that were published in the Splunk with the serial number information metadata that we just created. So you can see each data change event from a tag is going to create
Muted.
name, tag the value of that data point and the quality of that data point based on the event or the poll that Kepserver has of that particular tag. And additionally, what's also important is we have the timestamp of when Kepserver EX received that data from the device. So you can see quickly that what's great about the idea for Splunk is it creates these key value pairs automatically with all of these properties that you're used to seeing with the data coming from Kepserver EX. So that concludes the end of my demonstration. You can see it's pretty easy to start publishing data into Splunk.
Unmuted.
Great, thank you, Ray. Great demonstration. I'm going to go ahead and pass this over to Eric Dean on the Splunk side, who's going to just get more into that Splunk platform. So, Eric, if you are there on the line, we're ready for you.
I'm here. Can you hear me, Joanne?
I can hear you. Great.
And see my screen?
Yep.
Okay, perfect. All right, so you saw how Ray took data, raw data, OPC data into using Kepware and into Splunk, but I'll tell you a little bit more about Splunk and then show you what you can do with some of that data that you bring in through Kepware. So first off, got to show this. This is our safe harbor statement, and just telling you that I may make forward-looking statements and discuss product roadmaps, but keep in mind that these reflect our current expectations or subject to change. So you saw it. Okay, so who is Splunk? Who is that company with the funny name? Some of you, so it looks like some of you might know who we are and are using Splunk, but a number of you don't know. So this is a quick snapshot of who we are. We're headquartered Our primary headquarters is out of San Francisco. We have about 2,100 employees worldwide, over 11,000 customers now, and across over 110 countries. We provide both cloud and on-prem options for deployment, and a hybrid option too for those instances where you need some behind the firewall and some data you can put up in the cloud. And really our products are designed to fit your needs and are built as frictionless as possible. And what I mean by that is you can simply download Splunk software or sign up for an online sandbox, point it at your data, and you'll be up and running in minutes. So that's what we mean by it's frictionless. You don't have to put together a bunch of different software packages to get it all working. It's just out of the box, sign up, and start playing with it. We currently have over 80 of the Fortune 500, and our largest customers are indexing over a petabyte a day. So what is machine data, and why is it a big deal? Well, it's one of the fastest growing, most complex, and most valuable segments of data. All the web servers, applications, network devices, mobile devices, sensors, automation systems, all this technology infrastructure generates massive amounts of data, machine data, and it's often in unpredictable formats that are difficult to process and analyze using traditional methods. So Splunk can also bring in data as ratioed from your RTUs, your PLCs, your HMIs, and your OPC servers. So why is this machine data valuable? Really because in that machine data there's these traces or categorical records of behavior. It could be equipment behavior, it could be process conditions, it could be workers' actions that they're taking, cybersecurity risks, how your application's behaving. So this machine data really is a wealth of information that can give you really invaluable insight about your operations, and I'll show you some of that in a bit. But what our overarching mission is to make this machine data accessible, usable, and valuable to everyone. And really this is the mission that drives our company and our product priorities. So that's why we built a platform that can analyze this data and can be easily downloaded and launched. But how do we actually do this? How does Splunk process all this machine data that's often unstructured? Well, we provide an open, fully integrated platform. So what that means is we can collect data using many different means, including our partnership with Kepware. On the OT side of the house, we index the data, we can analyze the data. We have a machine learning toolkit with 20 different algorithms today and growing. Customers can build reports, dashboards on that data. And so it truly is, it works out of the box, and it truly is an end-to-end platform in a single product. And I encourage anyone who's interested after this call just to go to our website, download it, and try it out. It's also an open platform, so it's extensible from data collection all the way up to the UI dashboard and the reporting. We really want to give customers the ability to develop their own applications if they want to. Or we also have an app store called Splunk Base where customers can download apps that have already been built. Splunk's enterprise ready, so it has high availability, disaster recovery, role-based access control, scales to hundreds of terabytes a day, and as I mentioned, our largest customers indexing over a petabyte a day, which is pretty amazing. So at its core, the Splunk platform provides three primary benefits. Collect data from anywhere. We try to make this as open as possible to different data standards and are always adding new connectors and working with partners like Kepware. Search and analyze the data. So the core capability of Splunk is what's called SPL, or Search Processing Language, and this really gives you like you search the web, you can search your data and dig around and do troubleshooting in the raw data using schema on the fly technology, meaning we put the schema, we don't give the data structure on ingest, we give the data structure as you're searching it, which makes the tool very flexible. And the third benefit is the ability to rapidly deliver real-time insights. So this is data coming in real time. You can see all your numbers updating in real time, whether it's dashboards or reports or custom apps that you build for potentially for line workers to use. And we call all this operational intelligence. Just real quickly, I mentioned that we have over 11,000 customers who are currently using the enterprise license of Splunk. Includes a majority of the Fortune 100. And you can see the customers are coming across a diverse set of industries: retail, financial services, high-tech, government. And listed here are a few of the large number of customers that have started using Splunk to analyze machines outside their data centers. Here's a small set of those customers, everything from trains to planes to automobiles to wind farms. For example, Enernoc, which provides energy management solutions for commercial end users and utilities, is using Splunk for real-time visibility across their energy intelligence software platform. Zebra Technologies, over on the right, it's a company that builds printers and creates barcode, RFID, smart labels, and personal ID cards, is monitoring their printer manufacturing lines using Splunk. And then Konkar, it's a large utility based out of Croatia, is using Splunk to analyze data coming from their wind farm. So a lot of diverse use cases across the industrial realm. But let's take a closer look at one use case here, where Splunk's being used outside the data center. So it's a major retailer that's using Splunk to bring value to all the machine data that's generated by the robots, and the robotics and other automation systems powering their distribution center. And you can see the distribution center here with all these robots with their LED lights getting ready to start their day, I guess. So when you're a major retailer, as these guys are, sometimes the bottleneck isn't how fast you can sell something, but it's how fast you can replenish those products on the shelves. So time is truly is money here, and these robotic systems in modern distribution centers are quite complex, moving the product from the warehouse door to the shelf, back to the warehouse store, and it's really quite an amazing sight to see how automated these systems are. So this retailer wanted to get more insight into the operations of their robots and see how they're failing and when failures occurring. So they began monitoring the automation systems and error logs using Splunk, and began to recognize the subtle patterns of error. And so when precursors of error would occur. So using this machine data, they were able to predict issues before they occurred, to proactively maintain the systems, and significantly reduce failure and unplanned downtime. They did this not only by recognizing and predicting signals such as wheel wear, so they actually calculated diameter changes in the wheels in real time and predicted end of life and how to best replace those wheels, but also by using the historical record of data and the systems to identify the most optimum period to perform maintenance. So basically improve planned maintenance, reduce unplanned maintenance. So in a low margin business like retail, every second counts. And this retailer has used Splunk to improve throughput in the distribution centers by 4%, which is huge. Another interesting use case comes from the railroad industry. So New York Air Brakes, a manufacturer of air brake and train control systems for the railroad industry worldwide, and the company's train dynamics systems division is using Splunk to manage their inter-train forces. So this is the slinky factor that's inherent in these large freight trains. There's actually 6 inches of flex between the trains. So adding up 6 inches of flex across dozens of trains, you can imagine how a train can behave, much like a slinky. So with Splunk, they're able to use analytics to determine how best to drive the trains to reduce this slinky factor and save fuel. They then use Splunk's reporting capabilities, so the UI, to train engineers how to best control the acceleration and braking of the trains over long journeys. So it's like best practices fed in real time to the train operators to tell them how to operate the train. So through this, New York Air Brakes customers are seeing up to 8% fuel savings per rail segment when following these recommendations. For their largest customers, this can be $1 billion a year in savings, which seems astronomical, but remember that one of their customers uses more diesel fuel than the United States Navy. So this isn't just OpEx savings, which it is. I mean, there's huge OpEx savings, but it's also a huge benefit to the environment through less fuel burn. So whether you're using this machine data to improve the availability of your mechanical equipment in the distribution center or the performance of your customers' connected assets in the train example for New York Air Brake, Splunk's a powerful platform. But I want to take a step back for a minute and talk about another challenge for today's industry, which is cybersecurity, which is an area where Splunk really shines. So some of you may have heard about what happened in Ukraine this past December. So on December 23rd, in sub-zero temperatures, hackers took control of the systems of the power companies and instigated a huge disruption of power to the public. 230,000 people were left in the dark. And if that weren't enough, just to cut out power, the hackers also disabled the backup power supplies of 2 of the 3 distribution centers, leaving operators stumbling around literally in the dark. This was the first recognized attack on a control system where service was disrupted, but most definitely not the last. What makes this attack so interesting and honestly so scary is it wasn't just one control system. The hackers also disrupted the enterprise network, so making it difficult for employees to access the business systems that they needed in order to diagnose and dispatch the technicians to go fix the problem. At the same time, the hackers deployed a denial of service attack against all the call centers, which means customers couldn't call in because they got busy signals. So it truly was a coordinated attack across both OT and IT, which made it really difficult to identify the source and fix the issue. And months later, actually they changed firmware on some of the systems out in the field. So months later, they're still driving around manually changing breakers when needed, which also is a huge safety issue. For Splunk, this is a potential opportunity because Splunk gives visibility into the IT and OT data, and with that IT OT data, you can do analytics across a variety of use cases, availability, system performance, and cybersecurity. So now let's discuss how Splunk can be used for industrial ICS and SCADA data. And this is a little bit of a busy slide, but let me walk you through it piece by piece. So as you all know, industrial data is not a one-size-fits-all. Some systems have been running for decades, have legacy communication protocols, different hardware and software. Systems often have their own communication standards that aren't compatible with one another. You guys know the drill. Because of its flexible architecture, though, Splunk's an awesome solution for this, and it can ingest all these siloed communication protocols and really focus the user on doing analytics and UI instead of just data ingestion. And you can see here on the left side of the screen, Splunk's got a variety of native inputs, starting with native inputs, which is TCP, UDP, different logs. Also, Splunk also has a library of SDKs in Java, C#, Python that can deliver data directly to the Splunk pipeline. Our modular inputs allow Splunk users, Splunk forwarders to collect data from external sources. So it's an open framework that allows anyone to wrap a communication library in a Splunk native input, and from that point you can configure the connection to collect from remote sources. So we have already built modular inputs for MQTT, AMQP, CoAP, GMS, REST, and some of the more common sources of IoT and industrial data. The HTTP event collector is a new method to deliver events right into Splunk, which is pretty exciting for us. It can do this on massive scale. So the event collector allows you to instrument the assets at the endpoint or the applications using just a few lines of code, and then the events are delivered over the network with built-in authentication. And this supports hundreds of thousands of connections and millions of events per second, so it truly is scalable. And as you all know, some as I mentioned, some industrial data is proprietary, and it's for this reason that we have a partnership with companies like Kepware. And it's part of our mission to make this machine data accessible, and by making Kepware's library of protocol drivers part of the data pipeline, you get access to everything that they connect to. How about enrichment? So if we jump over to the right side of the screen, what do we actually do with this data once we get it in? So for enrichment, if you have information in your machine data like an asset ID, but maybe it has a funny indicator ID, that could be enriched by some external source, say an asset database with additional information about the asset like geolocation data, serial number, make and model, and you can do that in real time in Splunk. Or you can enrich the real-time data with information from your work order management system, like the maintenance date potentially, and I'll show you that actually in the demo. And ultimately, all this collection and enrichment is about bringing new insight to people who need it most, really your engineers, right, and your business users. And on the top up there, you can see the different things that you can do with Splunk. So you can do create your own UIs, create alerts, build dashboards, reporting, do prediction using our machine learning toolkit, and even develop your own apps. I just want to mention really quick. I know Eric and Ray talked a bit about this, but just want to reiterate how great it is to have Kepware as a partner. Really, the industrial data forwarder for Splunk takes in over 150 communication drivers that are supported by KepServer-EX into Splunk, and really it's a fantastic partnership for us, and it gives customers the best of Kepware's connectivity capabilities and Splunk's analytic features. And here's a few use cases that are where Splunk and Kepware have been deployed. There's actually many more, but you can see pretty diverse. We got commercial HVAC monitoring, clothing manufacturing, cabinet manufacturing, so both high-tech manufacturing as well as I guess we call it legacy manufacturing. Things have been going on for really centuries. Appliance manufacturing, packaged foods, and the list goes on and on. But instead of just talking about these use cases, maybe best is to jump into a demo to show you guys what this looks like in practice. So I'm going to show you some, I guess we call them best practices, or just some common ways that customers are using Splunk for OT data. So I'm going to build a baseline of my asset performance. I'll look at some patterns or seasonality in operations, monitoring trends and KPIs, using machine learning toolkit to identify anomalies and outliers, and then enrich the data. So let me flip over to the demo. Joanna and team, can you see this? My browser?
Yep, we can see it.
Okay, perfect. Okay, so here you can see data coming into Splunk. So this is raw data, not formatted in any way. It's alarm and event data coming from a log. So you can see there's a timestamp, a date, time associated with Splunk data. Splunk is indexed in time series format. It's got a type, so it could be a piece of equipment or a user, and it has a description of the event. So from this raw data, let's see if we can process it and do something at least a little bit more interesting. So here I'm going into our search application, and I can see my raw data here, and each one of these is an event coming in with a timestamp on it. And it has the source, and it has all the information we just talked about. So let's say, what if I wanted to search just for data in one of our generators? I know I have a generator 3, so let me quickly sort that. And you can see we went from hundreds of events down to 54. So automatically it's searching through this file, looking at, okay, where is generator 3, which events where is generator 3 present, and okay, it found generator 3, and here's timestamps for that. And I can click over to visualization. Actually, let me add a time chart here, then I'll go over to visualization. So I can add a time chart, and I want to count all of these different events that are happening on generator 3. So I have a table here now, and some dates I have a count, others I don't. So events are happening. I click over to visualization, I can see more easily where events are happening. Maybe I want to switch this. My boss likes a column chart, so we'll flip over to that, and now I can see where events are happening a little easier and on the dates. Okay, this is helpful, but what if I want to, let me go back to this data and look a little more closely at these events. What is in these events? Well, I can see emergency stop, emergency shutdown, oil pressure, emergency stop, generator 3 starting. Well, what if I just want to look at emergency events? I can actually go into the raw data here and click on it and say add to search. Now all of a sudden we've narrowed those 54 events down to 18. Again, it's in the table. If I go over to visualization, I can see, okay, this is interesting. I have 10 emergency events on September 24th and then 8 more on October 26th. Well, let's take a closer look at these. I can click on that, and it breaks it down to the events during the day, when they occurred, and it just breaks down those 10 events that were just indicated. So this is an example of how you can really go from raw data and create a quick dashboard and dive into events that are actually relevant. So now we're looking at emergency events for generator 3. So something else here, just to quickly go through this, is you can look at patterns in your data. So here's an example of, in that same log, we're looking for emergency events across all equipment and users. But we've broken it out into 3 shifts. So the 3 shifts, we put in the time range between the hours of 7 and 15, 15:23, and 23 and 7. Because this is all time-stamped, we can count by shift and see how many emergency events happen per each shift and represent it in different ways. Probably pie chart's the best. And here's something that's interesting, is that shift 1 had 21 of those emergency events, shift 2 had 4, and then shift 3 didn't have any. It's not even showing up. So that automatically tells us something about this shift. And of course, on any of the visuals, you can dive into the raw events and see what they look like, when they occurred, and do some more root cause problem solving there. Let me go back here. Okay, so that's looking at alarms and events, but also bringing data in through Kepware, through Industrial Data Forwarder. We could bring in OPC data, for example, and this OPC data looks a little different. You can see there's the timestamp again, but also there's a tag which indicates what the asset is, and also what the metric is, and then the value of that metric. So if I dive into this, we can do some interesting things with this data. This is wind farm data that we've simulated, bringing in through Kepware, and you can see. Let me click over here. So you can see all the timestamps and the power levels just in series format for all these different wind farms that we have. And if I visualize this, you can see it in a column chart, because that's the last thing I had up, but this is probably better represented in a line. And so I can see this is an average across all my wind farms, or sorry, windmills in my wind farm. So one number that's calculated every minute. And we can do a bunch of formatting options here. But also, what if I just wanted to see the last value, my current output from my entire wind farm? So here's I could change that over to a single value, see the value, see the trend line, which way it's going up or down. So this is just an easier dashboard for maybe an executive who just wants to see, hey, what's my current wind generation power? I could break this out. Let's say I want to do some further investigation. What if I want to see the power being generated by each turbine? So if I select turbine ID, I still have it on that single value, but I could flip over back to my line. Aha, now I can see the trend line for each turbine. So all I did was say basically split by turbine ID, and now we have the power being generated over time by each turbine. So just as easy as that, we can take OPC data from Kepware, load it in, and then start to do some interesting things with it. So let me go back to show a couple more things. I know we just have a few more minutes here. So there are some more advanced analytics capabilities in Splunk. Here we're looking at using the anomaly detection features. So right here you can see anomaly detection. And what we're doing is across each of these sources or fields, we're looking at did an anomaly occur. And you can see there's a few categories here where there are a lot of anomalies. And so this anomaly detection actually splits out by what's the probable cause or the field. And then lastly, just talk a little bit about enrichment, which I mentioned before. So we can enrich from external data sources, whether it's a relational database or your work order management system. And here what we're doing is we have that power for our field. So this is a single aggregate average power for the field, or actually minimum power. But we can also enrich that in real time with an external source. So we could look up last maintenance technician, get their number, last maintenance date, get the date, the asset ID, what is the asset. So you can actually give more context for your time series data in Splunk. So you do that enrichment in real time. And then a little even more advanced is we can enrich with geolocation data. So each one of our windmills in this example has a lat and long. So we use our geolocate feature and we can do one average power across an entire country. So we've told it geo countries. So Splunk automatically will take that lat long, group it into a country, and then do statistics on it. Right here we're doing just an average value, but you could do a lot more advanced statistics than just average value and do it by country. And we can do different geographies. We can do it by state or other geographies. So that's an example of what Splunk can do. And with that, I will pass it back to Joanne.
Okay, great demo and presentation, Eric. Really appreciate you taking the time to do this for us. I'm going to go ahead and take back presenter rights here and show my screen. And we have one more poll question here for everybody. And after hearing about all this great stuff from Splunk, we want to know, would you like to be contacted by a Splunk representative to receive more information about everything that Eric Dean from Splunk just spoke about? So if you would like to be contacted by them, go ahead and answer that poll question real quick. I'll leave that up for a few seconds. But again, great presentation, really compelling. And then once we're done with this one poll question, we'll move into the general Q&A where we can talk about, we've got some great questions coming in on the line here, so we can start answering some of those live with you now. All right, so it looks like we're waiting for a few more people to vote here. I'll leave that up for a couple more seconds. So vote if you want to, if you have a chance. And then I'll go ahead and close this out. Wonderful. So let's hop right on into Q&A. And I'll put some contact info up on the screen so you can write that down while we're going through this Q&A section. But let's search through some of these questions here. So Eric and team from Splunk that are on the line, we've had a lot of questions come through about Splunk, where it's located. So whether it's located on premise or on like a company intranet versus if it's located on the cloud. So you want to speak to that a little bit?
Yeah, sure. This is Eric. Can you hear me?
We can, yeah. Okay.
Yeah, so Splunk has two deployment options, actually three deployment options really. So we have an on-prem version, we have a cloud version, and then we have a hybrid version. So you can keep part of your instances behind the firewall if you need to, and then you can host some in the cloud, or you can keep it all on-prem or all in the cloud. So really it's up to you. prefer one over the other. It's all up to you.
Wonderful. So yeah, to answer a lot of the questions coming through, yes, you can have like a hybrid network then, is what it sounds like. What
Yes.
about syncing, data syncing across different cloud servers or local servers?
We might need to elaborate a little more on data syncing. That might be a specific
So
question. Maybe
someone
we can
is
follow up.
just asking in the case of failed internet connectivity, when that internet connectivity is reestablished, is there some sort of syncing that goes on?
Maybe I can pass it off to Terry. Are you on the line?
See if we can.
Yes, I'm here.
Yeah, we can hear you, Terry.
Great. Yeah, so for forwarding, it can definitely be cached on the forwarder side. So if there is a slow connection or something like that, the forwarder will cache and send as it can to the indexers, and the indexers can be either locally or on the cloud. So there's a lot of different ways to set up your environment based on your needs, and you can configure the amount of data that it actually stores or can store before it forwards to help you with latency issues.
Great. Thank you so much for that, Terry. We got a lot of other questions coming in. So report generation capability in Splunk, just a general question about maybe generating reports from Splunk, perhaps in other formats besides just seeing it through that web view.
Yeah, you can generate reports in a variety of methods. You can even build your own HTML dashboards if you want to. So we could create PDFs out of the dashboards and generate reports. So I won't go into all the different methods, but definitely online, if you search for Splunk and reporting, you can see some of the different methods that can be done there. But it's not just the online dashboard that you see.
Okay, great. Thank you for that, Eric. And then what about trend analytics? So is it possible in Splunk to see trend analytics that could forecast future potential issues or indicators?
Yes, absolutely. So we have a machine learning toolkit that currently has 20 algorithms, and one of them is for forecasting out your trend lines, and then there's other, of course, machine learning algorithms that can do other statistical means, whether it's logistic or linear regression. So depending on your specific case, you can use the forecasting algorithm, which I forget the actual specific algorithm that I use under the hood, but if you look for machine learning toolkit in Splunk online, you'll see those 20 different algorithms. So the answer is yes, you can definitely forecast out using multiple different means in Splunk.
Okay, great. Yeah, so we had another question come through, perhaps kind of related about raw data analysis and anomaly detection. So it sounds like you could probably use those same type of tools for that as well.
Yes, absolutely.
Okay, great. So let's see. We have a question about providing the licensing information for both Splunk and Kepware. So there's sales information, sales contact information for Splunk up on the screen right now, and then I'll pop up the information for Kepware as well. So anybody on the line that's interested in the licensing and how that works and everything, you can contact either of our sales team to get that information. So good question there. Then we got a question coming through about if the Splunk forwarder isn't being used and Kepware is the one that, connecting to a sensor, handling the communication with the sensor. This is coming in from Phil. So this has to do, it sounds like, with the Kepware connectivity and the driver connectivity. I think Ray has an answer.
Yeah. What we can do is leverage the universal forwarder on the same machine that KepServer EX is installed on. So KepServer will forward the data to the universal forwarder, and then the buffering capabilities built into the universal forwarder will provide you the ability to leverage that buffering capability. If you have your network connection down to the cloud instance
once that becomes reestablished, it'll forward that data to Splunk Cloud, for instance, to potentially multiple indexes depending on how you set up the universal forwarder.
Okay. Thanks so much, Ray. One last question for you, Eric Dean, on the Splunk side. Does Splunk Lite work with this solution, or is Enterprise required?
It depends on what your use case is and what you need to do. I would recommend going to our website and just seeing the features for Splunk. I guess specifically, are they asking if they want to use the industrial data forwarder? Could they use Splunk Lite?
Yes,
or?
I think that's what that might be referring to.
I see. Actually, I honestly am not sure. I've only used Splunk Enterprise with the industrial data forwarder. The Kepware guys, do you guys know?
About Splunk Lite working, I think we've only ever used the enterprise solution as well, so that's probably a good question to answer offline, so we can get back in touch with Rick.
I can follow up with that.
So good question there. All right, so that brings us just past the hour, so we're going to stop it there. But thank you so much for everybody who joined us. Really appreciated your presence on the webinar. Great job from the Splunk team answering questions and doing the presentation. And we hope to see you back here, people on the line, for some of our other webinars that are happening all the time. You can check them out on the website, what's upcoming. All right, thank you so much, everybody. Have a great day.